Good morning. In the previous lesson, we talked about speed, speed being the change in distance over time. And the formula for speed is speed equals distance divided by time. If we want to abbreviate that, we want to talk about that. The symbol for speed is V, so V equals D over T. I want to also, I've put a distance time graph up here for you, and let's talk about that as distance time graph. And this is part of our math connection as well, because I want to show you that using a graph like this is one of the ways that we find speed. We find speed by looking at slope. So with slope, we look at change in distance. And remember, delta is our, so to find slope, slope equals what we call rise over run. All right, and that is actually speed, okay? So let's change that back to our symbol. So, okay, so we've got our distance and we've got our time. So to find the slope of a line, we're going to take the change in distance and divide it by the change in time. So slope equals rise over run. And I know you will have been exposed to that in math. So this is something that we took a look at last week. We started taking a look at the issue of velocity. And we know that speed is simply one variable. So it's scalar. It's just one variable. It's how fast something's going over time. All right. The distance, and this is really, really important when we're doing formulas. We've talked about this before. We have to always indicate what measurement of unit we're using. So let's say kilometers here, and time we're looking at in terms of seconds, okay? So that's that. So this is what we're going to call here, good morning. I'm in my granddaughter's room doing this. So this is a velocity time graph over here. And our velocity time graph does a couple of things, because with velocity, we have a vector quantity. And a vector quantity talks to us in terms of there's two things that get measured. The speed gets measured, but direction also gets measured. So we would have a velocity time graph tracking how something goes. So I'm going to show you the symbol for velocity is very similar to the symbol for speed, except, so it's the V, but over top it's got a direction arrow. So is our object moving to the right, to the left, up, down, so there'll be an arrow over it, okay? So a velocity time graph would look like this. So we went this direction for a while, then we held steady, then we returned back to our original position. So the first part we would call positive acceleration. We would call the top, number 2, this would be zero acceleration. So that means it's holding steady, but time is still progressing, so we still have to indicate that time hasn't stopped. Our object just hasn't. So let's say that you pull out of your garage and you increase your speed to 30 miles an hour on your street. You hold it 30 miles an hour to the end of the street. You've got a stop sign down here, so you begin slowing down to get to the stop sign, and the stop sign, while we are slowing down, that is called negative acceleration. And we also can refer to that as deceleration. The word acceleration is basically a change in speed over time. So it can be negative, it can be positive. The word, we tend to think about the word as speeding up only, but in actual fact, it can be more than that. All right. So we're gonna talk about this a little bit more, particularly as we have our math connection here. But so let's talk about our math connection, because we have to be very careful about how we look at doing these things. So I'm first going to give you the formula for acceleration. So down here, acceleration is lowercase a as a symbol. So our acceleration is our final velocity minus our initial velocity divided by time. Okay, so that's how we factor acceleration. Now, something that's key here is that I've got up here at the top of the board, I have a little car going along a road. It is stopped here. So we can measure from two places. We can either measure from the back of the car, or we can measure from the front of the car. What we have to remember is if we measure from the front of the car for initial velocity, we have to measure from exactly the same point for final velocity. So I like to measure from the front of the car. So this would become velocity VI. V subscript I is how we would abbreviate that. It would travel along the distance, and when I was done, once again, I would look at VF or V final, and I would measure from there. So I'm measuring from exactly the same point on the car. Otherwise, you're going to get an error, okay? So what we want to know is speed and acceleration can change with time. Acceleration is the rate at which velocity changes with time. To increase in velocity, it includes any change in velocity. So they're following our examples of acceleration. You can have speed increases, you can have speed decreases, and you can have directional changes, okay? So this is our example of our formula for acceleration. Now, one of the things that we have to talk about is the fact that we're going to get an answer here because we're talking about velocity, and velocity already has speed and direction. Okay, so we have to measure speed and then add direction. So our velocity is going to be measured as, let's say, 20 meters per second. So our velocity here might be VF is 20 meters per second minus 1 meter per second divided by time. All right, so my answer in time, we're also going to measure in seconds, let's say. All right, so what I'm going to get is, let's say, 19 meters per second divided by, let's say we were going for 19 seconds. So we're dividing it by 19 seconds. What we're going to get is 1 meter per second squared. We have to measure time twice because we've got time here and we've got time here. So we have to measure time twice. So we always look at meters per second squared. It's not the distance that's squared, it's time squared, because time was calculated into the formula twice. So with this, the V here stands for velocity, not speed. Remember, with speed, there's no line above it, and that's how we can tell the difference between speed and velocity. Speed is just telling us how fast something is going. Velocity is telling us how fast something is going over time. So that's the key thing for today, is taking a look at the slope of a line. So that's our math connection. We have our formula for calculating speed, We have our formula for calculating acceleration. There will be more on this in the videos for today, and there's also going to be more on this as we look forward in terms of force and motion. So that is key. So I do want to go over again the unifying principle that we're talking about with this unit is physical forces affect the movement of all matter on Earth and throughout the universe. Our big idea is the motion of an object can be described and predicted, and that speed measures how fast position changes, and acceleration measures how fast velocity changes. So speed is measured, we look at speed in terms of how fast position changes, because we're talking about something that's moving from point A to point B, so that is position. And with acceleration, we're talking about how fast velocity changes, because velocity has direction. All right, this is kind of a big concept. I know it can be a little bit tricky at first. I have included all of this stuff in your notes for today and some examples of what those graphs look like. The homework for today will be put together and put in later today. I'm working on them. It's going to be your math connection. So I'm trying to find some relatively easy to follow problems for you to do. All right. Have a good day. Let's have a great week. Bye.